What we are going to do today is see how we can balance equations. This balancing is based on redox reactions, and the first method that we are going to adopt today is called oxidation number method. The rules for balancing equation using oxidation number method are outlined here. The first thing to do would be to assign oxidation numbers to all atoms in the equation. And in order to do this, you can refer to my earlier video on assigning oxidation numbers. Once you have gone through that, you should be able to determine the oxidation numbers of elements in the reactants and products in an equation. The second thing to do would be to identify those atoms that undergo a change in oxidation number. That would help us in determining which elements are undergoing oxidation and which elements are undergoing reduction. The next thing that we do is, once we know how many electrons are lost and how many electrons are gained, we know the increase in oxidation number or the decrease in oxidation number. Balancing is all about making the number of electrons lost in an oxidation half reaction equal to the number of electrons gained in a reduction half reaction. Once you've done that, add these numbers as coefficients and you should have a balanced equation. We will discuss an example here. The example that we have here involves the reaction between nitric acid and hydrogen sulfide to produce nitric oxide, sulfur, and water. The first thing to do would be to determine the oxidation numbers. So I've determined these numbers. For hydrogen, it's +1. The important aspect is here it's a regular compound where hydrogen is not a hydride, therefore the common valency or oxidation number is assigned. Nitrogen, when you determine the oxidation number, gives you a value of +5. This compound not being a peroxide or a fluoride, the regular oxidation number of oxygen is -2. Same is the case with hydrogen and hydrogen sulfide, +1. Sulfur has an oxidation number of -2. In the product side, nitrogen has an oxidation number of +2 and oxygen again -2. Now sulfur here has an oxidation number of 0. Hydrogen and oxygen in water +1 and -2. So the next thing we are going to do is look at those elements that undergo change in oxidation. On the left, you will find nitrogen has +1 oxidation, nitrogen has a +5 oxidation number, reducing to +2. Therefore, that's the reaction that undergoes reduction, or we can call it as the reduction half reaction. And for this reaction to take place, we need 3 electrons. Sulfur, on the other hand, changes its oxidation number from -2 to 0, which means is an increase in oxidation number, making this reaction an oxidation half reaction, and in the process it produces 2 electrons. That's the state. At this point we know what is the oxidation half reaction and reduction half reaction, and that's good enough to determine what the coefficients are going to be. Those were the rules that we are going to adopt for the next slide. Here the same equation, once again determining the oxidation numbers, identifying reduction half reaction, oxidation half reaction, and this is where we were in the slide before the last one. Now what we are going to do here is determine the number of electrons lost in the first one, Reduction half reaction is gaining 3 electrons. Oxidation half reaction is producing 2 electrons. We need to make these electrons lost and gained equal. Since the numbers are odd number and even number, what we do is we find the smallest whole number that is common for both of these. So you multiply 3 and 2, you get 6. So if the oxidation half reaction, sulfide changes into sulfur, if you can produce 6 electrons, which means you multiply 2 electrons by 3, will produce 6 electrons. Similarly, for the reduction half reaction, we need 6 electrons multiplied by 2, and it will produce 6 electrons. So the number of electrons lost in the oxidation half reaction is equal to the number of electrons gained in the reduction half reaction. The numbers 3 and 2 become the coefficients of hydrogen sulfide and nitric acid, so that we will have a balanced equation. When 3 becomes the coefficient for hydrogen sulfide, we also need to change the coefficient of sulfur in the product side. That becomes a 3. Now looking at nitric acid, we add 2 as the coefficient of nitric acid, which means the coefficient of nitrogen should also become 2. Now if you count the hydrogens and oxygens, you'll find that on the reactant side you have 8 hydrogens, 2 from nitric acid and 3 from hydrogen sulfide. So you need to balance the number of hydrogen atoms in the product side and the reactant side. So if you have 8 hydrogens on the left, a coefficient of 4 should make it 8 hydrogens on the right side. If you count the oxygen atoms on the right, you have now 4 oxygen atoms in water and 2 oxygen atoms in nitric oxide, makes it 6. Look at the coefficient of HNO3. 3 times 2 makes 6 oxygens on the left, so your equation is potentially balanced at this time. This is the complete balanced equation. I have a few examples for you here. Try balancing these equations using the same method. Pause the video at this point of time, solve those equations, come back and look at your answers. That's about it for right now. Please rate the video and post your comments if you have any. Thank you and have a great day.